Morning, students. Can you hear my voice? Okay, thank you. Okay. So last class I started first order nonlinear PD of first type, that is f of p comma q equal to 0, okay, type 1. I think I solved this in this type. So now I'm going to solve the third problem. Solve p square plus q square equal to n into pq. So first you should identify this is under the type f of p comma q, because here you have only p and q. Okay, so to find the solve means you should find complete solution, general solution, and a singular solution. And I told that for the type of f of p comma q, there is no singular solution. Okay, let us take z equal to ax plus by plus c be a solution of equation 1. So to differentiate with respect to x, dou z by dou x, is equal to p equal to a. Similarly, dou z by dou y, that is a q equal to b. If you substitute p equal to a and q equal to b in the first equation, you will get a square plus b square equal to n into ab. Actually here, usually in the last two problems, I write b in terms of a. B in terms of a. You can check it. But here, the last two problems, b is linear, so you can easily find b in terms of a. So even you can write a in terms of b also. A in terms of, but here both a and b are quadratic. Okay, you need to write b square minus NAB plus a square equal to 0, which is a quadratic equation in B, and also which is a quadratic equation A. Now I am going to solve this for B. So B equal to, okay, minus B. Minus B is minus of minus NA, minus of minus NA plus or minus root of B square. B square is minus NA whole square, B square minus 4, A is 1, C is A square divided by 2 into A. A is 1. So this is equal to NA plus or minus, if you take A square commonly, you will get A. So root of N square minus 4 by 2. So B equal to, so take A commonly, so A by 2 into N plus or minus root of n square minus 4. So now you substitute the value of b in equation 1. So z equal to ax plus b. B you should replace by this function of a plus c. So that is the complete solution of equation 1. Okay. So therefore, complete solution of equation 1 is z equal to ax plus b. B is a by 2 into n plus or minus root of n square minus 4. So please check it, into y plus c, where a and c are arbitrary constants. Where a and c are arbitrary constant. Okay. Now we need to find the general solution. To find general solution. So first you should write the complete solution of equation 1. So what is the complete solution? Z equal to ax plus a by 2 into n plus or minus root of n square minus 4 into y plus c. Okay, can take this is equation 2. Now substitute c equal to some function of a. C equal to some function of a. So z equal to ax plus a by 2 into n plus or minus root of n square minus 4 into y plus c is f of a. Now call this is equation number 3. So differentiate equation 3 partially with respect to a. Differentiate equation 3 partially with respect to a. You will get 0 equal to x plus 1 by 2 into n plus or minus root of n square minus 4 into y plus f dash of a. So this is equation 4. So eliminating between equation 3 and 4, we will get the general solution of equation 1. Eliminate a between equation 3 and 4 gives the general solution of equation 1. Okay. So now next singular solution. So we know that type 1, that is a function of p comma q, don't have singular solution, but we need to tell. Okay. So first again, complete solution, you should write it. So okay. To find a singular solution, SS means a singular solution. So complete solution of equation 1 is complete solution of equation 1 is again z equal to ax plus a by 2 into n plus or minus root of n square minus 4 into y plus c. So actually this is equation 2. So now differentiate equation 2 partially with respect to A, first with respect to A and then with respect to C. So if you differentiate partially with respect to A, you get 0 equal to x plus 1 by 2 into n plus or minus root of n square minus 4 into y. This is 0. This is equation number 5. If you differentiate partially equation 2 with respect to C, you'll get 0 equal to 1. 0 equal to 1. So this is equation 6. But 0 equal to 1, which is not possible, is not possible. So therefore, there is no singular solution for equation 1. Therefore, there is no singular solution. There is no singular solution of equation 1. Okay. So then I'm going to solve last one more problem in this type, and then I'll go to type 2. Okay. This is the fourth problem. Solve q square minus 3p, sorry, 3q plus p equal to 2. Okay, now this is equation 1. So you should take as usual, is that equal to ax plus by plus c be the solution of 1. So is that equal to ax plus by plus c is the solution of equation 1. So p equal to what? A, and q equal to b. If you substitute p equal to a and q equal to b in equation 1, you will get b square minus 3b plus a equal to 2. Okay. So in the last 3 problems, we write a in terms of b. Okay, but here also, sorry, in the last 3 problems, we write b in terms of a. You can check it. B in terms of a. Okay, but here also you can write b in terms of a. So for this, you need to solve the quadratic equation in b. So for this, to avoid that, I am going to write a in terms of b, because a is linear here. So a equal to 3b, 2 plus 3b minus b square. Now complete solution of equation 1. I write CS, complete solution of equation 1 is z equal to a is 2 plus 3b minus b square into x plus by plus c. So this is equation 2. So where b and c are arbitrary constants. So to find the general solution, next find general solution. So in the previous 3 problems, we take c equal to f of b, sorry, f of a. But here I am going to take c equal to f of b. So into. So now if you take c equal to f of b, then z equal to what? Z equal to 2 plus 3b minus b square into x plus by plus f of b. This is equation 3. Now differentiate equation 3 partially with respect to p. You'll get 0 equal to 3 minus 2b into x plus y plus f dash of b. This is equation number 4. So eliminating b between 3 and 4, eliminating b between equation 3 and 4, we get the general solution. Okay. So next is singular solution. To find singular solution. So you know that complete solution is what? Complete solution is z equal to, I think you can do this part easily because there is no singular solution for this equation. So I leave this part to you, and then I will go to type 2. Okay. Type 2. Okay. So for type 1, you can try to solve this problem. Solve p equal to e power q. This is the first problem. Second problem, pq equal to k. So both the problems you can try and get the answer. Type 2, Clairaut's equation. So general form. General form of the Clairaut's equation. So z equal to px plus qy plus function of p comma q. So where p equal to dou z by dou x and q equal to dou z by dou y. So now complete solution of Clairaut's equation is given by z equal to ax plus by plus function of a comma b, which is obtained by obtained by replacing p by a and q by b. So general solution and the singular solution can be found out as usual. As usual means I already explained before type 1. General solution, GS, and singular solution, SS, can be found out as usual. Okay. Now, first problem, do some simple problem initially, then solve. Z equal to px plus qy plus root pq. So as far as Clairaut's equation, you need to find one. It is enough to find the complete solution and singular solution. So there is no need to find the general solution. Okay, first you should find a complete and then find singular solution. Okay, if possible, you can find general solution. Okay, because you can the type one also from the complete solution, if you replace c by either function of a or function of b and differentiate partially with respect to a or b, and if you eliminate a or b, you will get general solution. But we are not finding general solution explicitly. Okay. Now, but for type 1, this should be essential. General solution should be essential. Okay. Now, we should find the complete solution first. First, you should identify this is a Clairaut's equation. So that is very important. Okay, you call this is equation 1. So equation 1 is Clairaut's equation. So because this is the form, z equal to px plus qy plus function of pq. Okay. Complete solution is z equal to kx replace p by a and q by b plus root of ab. We call this is equation 2. Okay, so just write the previous equation. Z equal to ax plus by plus root of ab. So now okay, this is to differentiate equation 2 partially with respect to a, will get 0 equal to x plus this is 0 1 by root 1 by 2 root ab. If you differentiate ab with respect to b, you get if you differentiate ab with respect to a, you get b. So from this, x is equal to what? X is equal to root b. Here you have root b, so minus root b divided by 2 into root a. Similarly, differentiate equation 2 partially with respect to b. So 0 equal to y plus 1 by 2 into root of ab into a. So y equal to what? Minus root a divided by 2 into root b. We call this is 3, this is 4. Now 3 into 4. If you multiply equation 3 into 4 gives you xy, okay, x into y. Here root b gets cancelled, root a gets cancelled, minus into minus plus 1 by 2 into 1 by 2, 1 by 4. So you get 4xy equal to 1. So this is the singular solution. This is the singular solution of equation 1. So this is enough for this problem. So we got a complete solution and a singular solution. Second problem. solve z equal to x plus qy plus p square plus q square. Okay, now so you can easily see that uh, this is Clairaut's form because z equal to px plus qy plus function of p comma q. So we call this is equation 1. So equation 1 is Clairaut's equation. Okay, complete solution is z equal to ax plus by plus a square plus b square. Okay, so there is no need to find general solution. So just I will tell you for one problem how to write the general solution of this type. Once you write the complete solution, you should replace b by what? F of a. So z equal to ax plus f of a into y plus a square plus, sorry, here, so, okay, sorry, there is a small mistake. This is minus b minus p square. So this is minus b square. B is what? F of a whole square. This is equation 3. If you differentiate partially with respect to a, differentiate equation 3 partially with respect to a, you will get 0 equal to x plus f dash of a into 1 into y plus 2a minus 2 into f of a into f dash of a. This is equation 4. So eliminate a between equation 3 and 4 gives the general solution of equation 1. Eliminate a between 3 and 4 gives the general solution of equation 1. Okay, next I'm going to find the singular solution of given problem. So to find a singular solution, so you should start from the complete solution. Complete solution is what? Is that equal to ax plus by plus a square minus b square. This is the complete solution. Now differentiate this equation partially with respect to a and partially with respect to b. Okay, differentiate. I think this is equation 2. Differentiate to partially with respect to a. So please tell anybody. 0 equal to x plus
2a.
Okay, x plus 2a. From this, what is x? X a. What is a? We need a. A equal to minus x by 2. Similarly, differentiate equation 2 partially with respect to b. We will get 0 equal to y minus 2b. This implies b equal to what? 2b equal to minus y, b equal to y by 2. Now we got the value of a and b. So substitute the value of a and b in equation 2, we will get the singular solution. So z equal to a is minus x by 2 into x, b is y by 2 into y plus minus x by 2 whole square minus b square y by 2. To simplify this, you will get z equal to minus x square by 2 plus y square by 2 plus x square by 4 minus y square by 4. So if you add these two, we get minus x square by 4. If you add these two, we'll get plus y square by 4. The left hand side is z. So final answer. Okay, you can stop here. Or 4z equal to 4z equal to y square minus x square. So this is the singular solution. Singular solution of equation 1. So I think here the you can easily find a and b. Sometimes it is very little bit difficult to find a and b. Okay, because here a is linear and a is linear, and there is no b with a. So suppose if we have b here, suppose x plus 2ab, here y minus 2ab, then it is very little bit difficult to find a in terms of x or in terms of y, b in terms of x and y. Okay, so next problem we will see those type of situations. Okay, problem number 3. Solve z equal to px plus qy plus p square q square. Okay, so first you should identify this is Clairaut's form, because z equal to px plus qy plus some function of p. So we should write equation 1 is Clairaut's equation. Now, therefore, the complete solution, I will write in the short form. CS complete solution is z equal to, you don't write in the exam CS, z equal to ax plus by plus a square square. This is equation 2. Now, to find singular solution. Okay, so to find singular solution, you need to, the idea is you need to differentiate equation 2 partially with respect to a and then partially with respect to b. You should find the value of a in terms of x and y and b in terms of x and y, and you should substitute the values of a and b in equation 2. So this is the idea. Okay, so remaining thing is up to you. So how you are simplifying the equation. So differentiate equation 2, differentiate equation 2 partially with respect to a. You get 0 equal to x plus this is 0 to a b square. Okay, this is equation 3. Similarly, differentiate equation 2 partially with respect to b. So then you'll get 0 equal to y plus 2a square b. This is equation 4. Now from 3, what is x? Because it is a little bit difficult to find a in terms of x. So if you write a means what? A equal to what? Minus x divided by 2b square. Okay, but I need a in terms of only in terms of x, not in terms of b. So that's why x is equal to minus 2ab square. Similarly, equation 4 implies y equal to minus 2a square b. This is equation 5 and 6. So now 5 divided by 6. So that means x divided by y. So x divided by y is b by a. B by a. So I b by a. This implies x by b, x divided by b equal to y divided by a is equal to, I will take this is equal to some constant 1 by k. So from this a equal to ky and b equal to kx. B equal to kx. Okay. Now I'm going to substitute a value and b value in equation 5. That is x is equal to minus 2 into a is what? Ky. B is kx whole square, b square. And then I'm going to find the value of k first. Once you find the value of k in terms of x and y, you should substitute the value of k here and here. Then you can get the value of a and b in terms of x and y. And then finally, you should substitute the value of a and b in equation 2. So that is the remaining process I explained you. So now our aim is to find the value of k using either equation 5 or using equation 6. Okay, now equation 5, I'll write equation 5. Equation 5 is what? X is equal to minus 2 a b square. So we know that a equal to what? Kx, you can check it. A equal to ky and b equal to kx. Okay, now x is equal to minus 2 a is ky and b is kx whole square. So now if you simplify this, you will get minus 2 k cube k into k square k cube xy equal to x. So you can cancel x and x. So k cube equal to minus 1 by 2 into I think here x square is 2k cube. I think here x square. Okay. So x is equal to minus 2k x square y. So if you cancel x and x, you get 1 equal to minus 2k k into k square k cube. So suppose if there is any mistake, please point out y. So this implies k cube equal to think I missed again one x here. After cancelling x, here I have x here, k cube equal to minus 1 by 2xy. So k equal to minus 1 by 2xy whole power 1 by 3. So this is the value of k. Now a equal to ky, k equal to what? Minus 1 by 2xy whole power 1 by 3 into y. Similarly, b equal to what? Kx, k is minus 1 by 2xy whole power 1 by 3 into x. So we got the value of a and b. Now I'm going to substitute the value of a and b in equation number 2, that is in complete solution. Okay, what is the complete solution? Okay, I will write in the next page. So z equal to equation 2 implies z equal to ax plus by plus a square into b square. Okay, now what is a? I will write here a because I need a equal to minus 1 by 2xy whole power 1 by 3 into y. Similarly, b equal to minus 1 by 2xy whole power 1 by 3 into x. Okay. Now substitute these two values here. Minus 1 by 2xy whole power 1 by 3 into y, and x is here, plus b. b is minus 1 by 2xy whole power 1 by 3 into x, and y is here, plus a square plus b square. A square is minus 1 by 2xy whole power 2 by 3 into y square. B square is minus 1 by 2xy whole power 2 by 3 into x square. Okay, I think these two are same. Okay, so that's why I'll write this is equal to twice xy minus 1 by 2xy whole power 1 by 3. Just I am adding these two. I got this one. Okay, now plus x square into y square minus 1 divided by 2xy. Here also minus 1 divided by 2xy whole power 2 by 3. So just add the power, you get minus 1 by 2xy whole power 4 by 3. So this is equal to what is common in these two expression. This is the x square, this is y square. So I think xy is common, and also minus 1 by 2xy whole power 1 by 3 is also common. So what is remaining? Remaining here 2, and then plus I take xy, so remaining you have xy into minus 1 by 2xy whole power 1 by 3 I common, remaining you have power 1 only. 1 by 3 plus 1 is 4 by 3. Now this is equal to xy minus 1 by 2xy whole power 1 by 3 to xy gets cancelled, so minus 1 by 2. So 2 minus 1 by 2 is 3 by 2. Okay, so you can write this is equal to 3 by 2. In the next step, you can, okay, next step is you can write. So z equal to 2 minus 1 by 2 is 3 by 2. What is remaining? Xy, okay, xy into minus 1 by 2xy whole power 1 by 3. Now I am going to take a cube on both sides because I want to eliminate this 1 by 3. Z cube equal to 27 divided by 8 x cube into y cube into minus 1 by 2xy. So I think from this you can cancel xy and xy. So we get 27 x square y square minus 27 x square y square by 2 into 8, 16. So the final answer is 16 z cube. Final answer is 16 z cube plus 27 x square y square equal to 0. So this is the singular solution of equation 1. Singular solution of equation 1. Okay. So I will start the last column. Solve z equal to px plus qy plus c into root of 1 plus p square plus q square. So actually you should find out again, this is a Clairaut's equation because these are equal to px plus qy plus function of pq. We call this is equation 1. Equation 1 is Clairaut's equation. Complete solution. Complete solution is z equal to instead of p, you should write a. Instead of q, you should write b, ax plus by plus c into root of 1 plus a square plus b square. We call this is equation 2. So as usual, you should differentiate equation 2 partially with respect to a and partially with respect to b and find the value of a and b in terms of x and y. You should substitute those values of a and b in equation 2. You will get the singular solution. Okay, now differentiate equation 2 partially with respect to a. You get 0 equal to x plus c by root of, if you differentiate root of 1 plus a square plus b square, you get 2 into root of 1 plus a square plus b square into 2a. So 2 gets cancelled. So x is equal to minus CA or AC divided by root of 1 plus a square plus b square. Okay, keep this. From this, actually, I need what? I need a. What is a? A equal to minus x into root of 1 plus a square plus b square divided by c. Okay. Now, okay, you keep as it is. Now differentiate equation 2 partially with respect to b. Then what you will get? Differentiate equation 2 partially with respect to b. So similarly, you can do 0 equal to y plus c divided by 2 into root of 1 plus a square plus b square into 2b. 2 gets cancelled. What is y? From this equal to, I'll write y here, y equal to minus bc divided by y equal to bc, okay, y equal to minus bc divided by root of 1 plus a square plus b square. So from this, what is b? B equal to minus y into root of 1 plus a square plus b square divided by c. Okay. So now I am going to square x these two and add x square plus y square, and then I am going to find the value of uh, 1 plus a square plus b square. So now call this is next page. Okay, I think now time is 9:45. What about your next hour? I need only 5 minutes. If you don't have next hour, I will finish it. Otherwise, I will finish it tomorrow. It's up to you.
We have next hour, sir.
Next hour you have class. Okay.
Yes, sir.
Okay, then I will continue this problem tomorrow or not tomorrow. I think Saturday. Okay. Otherwise, you will try this problem, fourth problem. Okay, thank you. If you have any doubt, you can ask to me. Otherwise, you can leave the session.